I'm Russell.
I'm Will, and we're here today to teach you math the Oberster way. If you like to miss class like Ayako or Jake, then allow us to teach you for goodness sake.
Listen up real good, don't talk during class. If you do, the test will burn your... Esther, yes Jill, we're talking about you. You girls make class sound like a zoo.
You ready, Russell?
Oh yeah.
Let's go. U-Substitution, gonna get me a solution with a math and rap fusion in this calculus institution. U-Substitution, teaching method evolution via rhythmic elocution. This is a calculus revolution.
Turn right now to page 338. We're putting number 27 on your plate.
This is problem number 27, the integral of this value, or this expression. And so, first thing that you notice with this problem is that this is not something that we've memorized. This is not an integral we've memorized. But what you can also see is that secant squared of x is the derivative of tangent of x. So that means we should use U-substitution to find this value. So I'm going to set u equal to tangent of x, and so the derivative of u, or du, equals secant squared of x dx. Now I'm going to substitute these values into the integral. So it's going to now read the integral of u to the 1/2, because the square root of u is the same thing as u to the 1/2, du. And now this is very easy to find the value of. All you have to do is raise it a power and multiply it by the reciprocal. So the answer is going to be 2/3 u to the 3/2 plus the constant of integration. And then now I'm just going to substitute tangent back into it for u. So the answer will be 2/3 tangent x to the 3/2 plus c. And that's how you find number 27.
That was really easy, wouldn't you say? Marla would have gotten it right away.
Wait, who?
Marley knows she sits in my row.
No, it's Mara. You learn names real slow.
We pause for a second. Who cares about work? Gotta watch Russell try to do the jerk. And now I think it's time to talk about the Browns. For some reason Kenny likes those clowns. U-Substitution, gonna get me a solution with a math and rap fusion in this calculus institution. U-Substitution, teaching method evolution via rhythmic elocution. This is a calculus revolution. Let's move on and give another a try. Same page, number 65.
Okay, this is number 65 from our book. Again, we don't know how to anti-differentiate this from memory, so we need to use one of our techniques. And the reason we'd use U-substitution is because there's a difference of power by 1. So up here there'd be an imaginary 1. You have to imagine that. So you have 2 and a 1. So that tells you it's a U-substitution. And in making our u, you want it to be the biggest term possible. So here we'll make u x squared plus 1. And then take the derivative. So du equals 2x dx. But as you see, we can't take this and plug it into here because this is x dx. Well, this is 2x dx. So therefore, divide this by 2. And you have half of du equals x dx. So now we could take this and substitute it into our original equation. So you take the half, which comes from there, and then the integral of 1 over u du, which is also u to the negative 1. And then we need new limits of integration. And we cannot use the x equals 1, x equals 3. So we need to get them in terms of u. So in order to do that, our beginning limit is x equals 1. So we'll do u of 1 by putting it into this equation, putting 1 in for x. So it equals 1 squared plus 1. which equals 2. So our first limit is 2. And then our upper one is 3. So u of 3 equals 3 squared plus 1, which equals 10. So basically we took our u equation and changed our limits of integration from x's to u's. So now we can solve this. So it's 1/2. The antiderivative of 1 over u is ln of u. So ln of top, which is 10, minus ln of bottom, which is 2. And then when you simplify this on your calculator, it'll be about 0.805. And you always want to do 3 decimal places to get a 5 on the test because they're picky about that. And that's our final answer. We hope you learned something new today.
If you didn't, well, that's not okay.
Go out and do well on the test. Aim for a 5 and give it your best. Word!